This video is on work, which is force times distance. And so here I have a triangular trough that's filled with water up to a level of 1.5 feet here. And I want to find the work done in pumping the water out over the trough. So here's the water trough again. And so the distance across here is 3 feet, and then the length of the trough is 5 feet, and then the height here is 2 feet. And then the water here is up to a level of 1.5 feet. And so what I'm going to do to find the work that's needed to lift the water to the top of the trough here, I'm going to divide the water here into 6 slices like this. And then we're going to find the work that's needed to lift each slice to the top. And so here's slice number 1, and this is the ground right here. So this is the height of 0, and then right here this is 0.25. And so I'm going to use the midpoint, which is 0.125, as the distance from the ground for this slice of water. And so to get the to find the work that's needed to lift this slice of water to the top here, then what we need is the width. We need the distance from here to here, and therefore we need to know what is the equation of this line is. And so let's go find the equation of this line. Once again, the distance from here to here is 3 feet, and therefore this point right here, this is 1.5 for the x, and then the y is 2. And then this point, of course, is 0, 0. And therefore this line here, it passes through the point 0, 0, 1.5, and 2. And the slope of this line will be 4/3. And so the equation for this line will be y minus 0 equal to 4/3 times x minus 0. So we get y equal to y equal to 4/3 times x, or x is equal to 3/4 y. And so when x right here, this is 0.25, and then I'm going to use the midpoint right here, which is 0.125. So when y is 0.125, in the place of y here we have 0.125, then the corresponding x is 0.938. And therefore the distance from here to here would be 0.1876. And so the height here for this triangle right here is 0.25. And so we do 0.25 times 0.1876, and that will give us the area of this triangle, which is 0.469. The length here is 5 feet, and so the volume of this slice of water would be 0.0469 times 5, and that will give us a volume of 0.2345. And then the weight of this slice of water will be 62.5, and here we're making the assumption that water weighs 62.5 pounds per cubic foot, and we'll get 14.65 for the weight of slice number 1. And so the work will be force times distance, the force, which is the weight, and then the distance from here, from 0.125, which is the midpoint right here, right in the middle of the triangle, is 1.875. So the work will be 27.48 foot-pounds for slice number 1. And here's slice number 2. Right here, this is 0.025, and right here, this is 0.5. So right in the middle, y will be 0.375. And then the corresponding x, when y is 0.375, x would be 0.2813. And so right in the middle right here, y is 0.375, and then from the y-axis to the graph here, x is 0.2813. And so the width right here, the distance from here to here, would be 0.5626. And so the area for this trapezoid right here will be the 0.5626 times the thickness, which is 0.025. And that will give us an area of 0.1406. And then to get the volume for this slice, we just multiply the area by 5. And that will give us 0.7032. And so the weight for slice number 2 will be 62.5 times 0.7032. That'll give us 43.95 for the weight. And then the distance from 0.375 up to 2 here, that distance will be 1.625. And so the work will be the weight times the distance, and be 71.42. So that's for slice number 2. And here's the slice number 3. The work is 100.71. Slice number 4, the work is 115.36. Slice number 5, the work is 115.36. And then slice number 6, the work is 100.71. And so altogether, we'll get, so we add all these values right here, work for each slice, and then we'll get 531. And so the work that's needed to pump the water, this amount of water here to the top, will be 531 foot-pounds. And so we got the 531 by dividing this water here into 6 slices. And now let's divide it into an infinite number of slices so we can get the exact answer. Here's the ith slice. And so let's call the distance from the ground to the middle of the slice here, let's call it y sub I star. And then the distance from here to here will be 2 minus y sub I star. And therefore, and then let's call the distance from the y-axis to the graph, right at the middle right here, let's call it x sub I. And so the width of this ith slice would be 2 times x sub I. Recall that the equation of this line right here is x equal to 3/4 times y. And so at y sub I star, when y is equal to y sub I star, then x sub I will be 3/4 times y sub I star. And so the distance from here to here would be 2x sub I, which is 2 times 3/4 y sub I star. So we get 3/2 y sub I star. And so to get the volume for this slice, it will be the 2x sub I, be the distance from here to here, times the thickness, and let's make all thickness the same. And so let's call it delta y. And then times the length of the slice, which is 5. And so this is the volume of the ith slice. And so the weight of the ith slice, which is multiplied by the 62.5. And so the work that's needed to lift the ith slice to the top will be the weight times the distance. The distance will be 2 minus y sub I star. And then simplified everything, we'll get 468.75, and then times 2y sub I star minus y sub I star squared, and then times delta y. So once again, this is work that's needed to lift the ith slice to the top, and then here's the work that's needed to lift all slices, an infinite number of slices to the top. It'd be the limit of this sum is n approaching infinity. And just like before, if this limit here exists, we defined it as the integral from 0 to 1.5, 0 to 1.5. And then here's the 468.75, and then 2y minus y squared. And then the integral for 2y will be y squared. Integral for y squared is y to the third dividing by 3. And evaluating from 0 to 1.5, then we'll get 527.34375 foot-pounds. And now we compare this answer here to the answer that we got when we divided this, when I divided this water here into 6 slices, and then the work, what we got, the answer that we got was 531 foot-pounds for 6 slices, and then the work that's calculated using an infinite number of slices, 527.34, and then we can see that the two answers are very close. And that's the end of the video.